Hey guys, welcome to the 8th video on muscles. Last time we met, we have been looking at this picture that describes what happens during a muscle twitch, which is a single period where we have both contraction and relaxation with a little bit of something called a latent period in the beginning. Um, so this has a X time scale of 0 to 140 seconds. We're about to look at the same twitch, but we just made the bottom of our graph, the x-axis, a little different. So now it goes from 0 to 300, okay? But still we have stimulus. There's a little latent period in there. It's just hard to see. Contraction, relaxation. A single stimulus, so a single action potential, in other words, is going to give me a single twitch. But now I want to start changing things up. Now what I want to do is stimulate right here, have a twitch. So contraction, then we start to relax, and we relax, and we relax. And before we relax all the way, we stimulate the muscle again. We, give it more acetylcholine, get more action potentials going. And when we do this, we get another contraction, but check it out. First contraction peaked there. Second contraction peaked right there. More tension. And then we relax a little bit more, but we don't let it relax all the way down. Nope, nope. And then we stimulate again right there, and we contract again, and we get even more tension. This ability to increase the amount of tension by stimulating the muscle over and over is called wave summation. It should remind you of what happened with graded potentials. It totally should. And we can keep going, stimulate, more and more contraction until we get to a maximum state of contraction. The max state of contraction is called tetanus. This is called incomplete tetanus because we allowed some relaxation to happen in between contractions. We don't have to do that though. I could stimulate just over and over and over and over and over and over again. And I don't ever allow the muscle to relax. So my graph here just goes straight on up. And we get to that maximum tension. That is called complete or fused tetanus. So maximum muscle tension is called tetanus. I can get there, either complete or incomplete, by doing wave summation, which means I'm stimulating the muscle over and over again. I'm either letting it relax a little bit in incomplete or not relax at all in complete tetanus. Now you might wonder, well, how does this work? Here's the key. Every time you stimulate the muscle again, the sarcoplasmic reticulum lets out a little more calcium. A single twitch doesn't release all the calcium from the sarcoplasmic reticulum. So, if you stimulate a muscle cell, it releases some calcium from the SR. We move some tropomyosin, and we get some contraction. But if we stimulate it again, we release more calcium, which can add to the calcium already released on the first one. Now we have even more calcium the second time around, which means we move even more tropomyosin, which means we can allow even more myosin to grab onto actin and generate even more pulling, thus even more tension. That's how it works. All right, now you may see this word tetanus and think, well, does that have anything to do with a tetanus shot? And the answer is, well, kind of, sorta. There are these bacterium called Clostridium tetani, and you can also often find them in like the little crevices that are on a rusty nail or rusty barbed wire here. And what this bacterium does is it makes this toxin. There we go. And what that toxin does is it causes motor neurons to be crazy hyperactive. So you get all these muscles contracting like crazy. There's the tetanus part. There's a horse with tetanus. This is a baby, and this is neonatal tetanus going on right here. So you don't want this. So make sure you get a tetanus shot. If you're going to step on a rusty nail, or if you're going to climb over some rusty barbed wire, get your tetanus shot first. All right. On that note, we are now going to move to a whole new topic. So, deep breath, pause it, go get a cup of coffee, and let's begin. Look at this guy doing a standard dumbbell biceps curl right there. He is starting in an extended elbow position. He is ending in a flexed elbow position. His biceps brachii is the main mover there. His brachialis and his brachioradialis are going to assist. Now, this type of muscle contraction is called an isotonic concentric muscle contraction. Let's break this down a little bit. All right, obviously, muscles are contracting. That's why we have muscle contraction here. Isotonic refers to the fact that the load on the muscle is staying the same. Iso means the same. The tonic refers to the tension. So the load, the weight, the dumbbell isn't changing in mass as he moves it. So the load on the muscle is staying the same. It's isotonic. Concentric means towards the center, because the two ends of the muscle are each going towards the center, and that makes the muscle get smaller. So an isotonic concentric muscle contraction is one in which the muscle gets shorter and we move the load, and that load doesn't change as we move it. Okay, let's look at some graphs of this. Here in this bottom graph, this is showing me my muscle length. So originally my muscle had a length, and we're calling that length 100%, okay? But then the muscle contracts, and the length gets smaller. That's the concentric part. Here is the tension part. So the muscle starts contracting, and tension starts to develop, and tension develops and develops and develops, but we don't do anything. The muscle doesn't actually change its shape until we've achieved just enough tension to move that load. If I go back for a second, in this diagram here, we had 3 kilograms. So the muscle doesn't shorten until we've got enough tension to move 3 kilograms. Now here's the key. This period right here, the tension does not change. That tension does not change. That is the isotonic part right there. All right, so this is isotonic concentric contraction. There is also isotonic eccentric contraction. Okay, so suppose you went to your home gym. I don't know if that's in your basement, your garage, wherever it might be. And you lie down on the bench that you have there. You load up the barbell with 3 45-pound plates on each side. So you got 315 pounds. And now you slowly lower it to your chest. That is an isotonic eccentric muscle contraction. Okay? Isotonic because the weight, the mass here is not changing. Eccentric because we're generating tension, but the muscle is getting longer. If you did this with the bench press, like in this example here, you would feel your pectoralis major muscles. There we go, pec majors. You're gonna feel them stretching. They're stretching, but they're generating tension. Stretching, but generating tension, an amount of tension that does not change. Now, this is why the bar doesn't just crash into your chest, because you're able to generate this tension while the muscle cell is lengthening. It's like you're using the brake pedal, okay? You are generating tension to lower a weight. If you lift weights and you're familiar with doing negatives, this is what this is all about. All right, let's look at I guess, you know what? We'll stop here. We'll pick up next time with isometric contractions. See you later.